Today we are going to discuss about microcontroller. This is also an extended version of your microcomputer system, unlike microprocessor. So before we start with the 8051 microcontroller, we'll try to find out what is the basic difference between the processor and the microcontroller. The main differences lies only with respect to the memory. In case of microprocessor, we will have a memory, RAM as well as a ROM, and the IO. Everything are kept separate. Whereas in microcontroller, everything will be kept in a single chip. As they are kept separately, in case of microprocessor, the amount of data which we are going to use is of more convenient in case of 8051 microcontroller. And similarly, when we go for a microcontroller, we cannot have this flexibility, but at the same time we can provide them fixed amount of RAM as well as ROM. Microprocessor based system are expensive because the amount of RAM can be separate, the amount of ROM can be separate, the amount of data can be accessed can also be made different. Whereas here we cannot have that provision, everything has to be kept in a fixed analysis. And it can be used for a general purpose, but whereas in case of 8051 microcontroller, it cannot be used as a general purpose, it can be used only for a specific application. So 8051 microcontroller, in general it is a 8-bit microcontroller. So all the operations in 8051 microcontroller basically of 8-bit, placed with the 8-bit data. As we are saying about 8051 microcontroller, there's a similar version of microcontroller is also available, which lies on the same existing features, namely input IO ports, RAM, ROM, IO pins, serial ports, interrupt, as well as the timers. The one important commonality we could able to see in there are the majority about the size of RAM and ROM. But generally we have sufficient enough with 8051 with the 4K ROM and 128 bytes of RAM. 8051 features, if you see, there are many features we have in par with 8051, but the three important features which highlights the importance of 8051. The one is 32-bit bidirectional IO pins. Why 32 pins? Because there are 4 ports are going to be there in 8051. Each port will have 8 pins, but they are saying that it's of 32. So 4 into 8 is 32. So there we have a 32 bits of individually addressable IO lines. 2 timers will be used for timing and counting operations, and 1 port is meant exclusively for serial communication. So a pin diagram of 8051 falls on these category. If you see, it is a 40 pin IC, 4 ports, P0, P1, P2 and P3 will be there. Each port will have 8 pins. If we see clearly from the pin diagram, one thing we could infer is nothing but each of the ports can able to perform the dual operation, whereas only the port P1 will perform a single operation. For instance, this P3.0 is meant for IO, at the same time it can be used for receiver communication. Pin number 20 is ground, pin number 40 is VCC, and apart from that we do have a certain control pins like EA bar, VPP, PSNE bar, and we will try to see each and every pin diagram in detail in the coming slides. Crystal oscillators, we have pin number 18 and 19, and they are meant for generating the operating frequency, clock frequency, which is of 11.059 to with a structure of two capacitors are connected in parallel in series with a quartz crystal oscillator, and the capacitor value of 30 picofarad, and two crystal oscillators we mentioned. If we want to connect one crystal oscillator with ground, the other oscillator, a crystal oscillator pin, will be connected as no connection. We have a pin called reset pin. Usually we know the pin, the name reset. It will reset the content by 0. Here the content of what? The content of register will be made as a 0. Right? What are all the content of registers in previously before executing this RST instruction? It will now becomes 0 once it executes this instruction. We have a enable pin EA is the external access which is exclusively meant for connecting this. So this is an active low pin. So whenever we need to connect, this must be kept as active low pin. PSENA as well as ALE both are active low. Program store enable. So this is a pin is exclusively meant for external way of communication. Data memory we call them it as 1, and the code memory we put them as. An ALE pin is used meant for multiplexing addressing data lines. So this we have seen in the pin number there AD0 to AD7. So whenever we want, there is a combination of address as well as the data. In order to separate the address separately and the data separately, this ALE pin is used. IO ports. There are 4 ports are available, we clearly mentioned, right? Port 0, which is min. So when ALE pin is 0, it tries to provide the data lines D0 to D7, and when the ALE pin is 1, it has an address ranging from A0 to A7. And apart from that, it is also designed to perform the port as an IO port also. Similar kind we could exist in port P1 and P2, and they are meant exclusively for performing the higher order as well as the lower order address lines. When we say lower order address lines, A0 to A7, and higher order means A8 to A15. So this differentiation is come with respect to 8051. It is a data is of 8-bit, address is of 16-bit. Port P3. Port P3 is exclusively meant for serial port communications. There are 8 pins are available, and each of these pins are meant exclusively for serial port communication, and 2 of the pins are exclusively meant for the interrupts, and 2 for the timers, and one for writing and one for the daily operation. Do you know what is an interrupt? Interrupt is nothing but the temporary suspension of current executing program or the instruction. So for example, for instance, when you are talking, if I interrupt, please don't talk. That intervention we call them it as an interrupt in 8051 microcontroller. And this is a quite quick summary of this 8051 pin diagram descriptions. VCC is meant for the ground and VSS is meant for the supply, and P0.0 to 0.7 as 8 pins are meant exclusively for drawing port P0 as a AO port. Similarly, port 1 8-bit and bidirectional. Port P2 is meant only for accessing an external data memory, whereas port P3 is meant for both bidirectional IO as well as meant for special features which are explained. EA pin ALE has a specific combination of this data which is meant for